This is a router table I recently built. Top is made of 1.25" clear Lexan bullet resistant plastic that was salvaged from a convenience store that was tore down. This was a piece that was pretty scratched up, so I really couldn't use it for furniture. So I thought I'd give it a try and see how it worked out for a top. And machine's pretty good. The only thing you have to do is slow your router down as slow as it'll go with a variable speed router, or it'll just melt. I use a lot of black plastic. This is HDPE plastic that I buy as salvage or waste from local manufacturers that they can't use it because the pieces are small or don't fit their purpose. It's pretty amazing stuff. I'm able to use it for a lot of things. These inserts, I made several of them. They fit in the routed hole. There's some screws around the perimeter that if I have to adjust the height to make it flush, they're there. Or if I change materials, I can adjust it to fit that material. I also have a sacrifice plate in the back of the, or in the front of the fence here with different size slots for different size routers. It just has 2 screws. As far as the router itself, it's just a 3-horse router that I had been using for quite some time. It's a plunge router. I didn't use the plunge hookup on it because it just wouldn't work out for what I had. The router itself, I have it mounted in a cage, and what I have made here is a router lift. The lift, I'm using bearings. These are actually bearings out of roller skate wheels. These are very plentiful and very reasonable to buy if you needed some. I cut a groove in the plastic, and if the bearing fits in that groove fairly snug and it runs up and down, and there's actually no movement at the router bit itself. This crank you see right here, this is what moves the system up and down. It's a 1-to-1 ratio, so it's not that fast, but it does work well. The gears I use are from a company called eTrailer.com. I stumbled on these because I was looking for some type of gear to run right angle drives. And I think they're about $10 for a couple of them, or 2 or 3 of them. And you can get them for 1/2-inch shaft or 5/8-inch shaft. You just drill a hole in the middle of the shaft, put a pin in, and these slide right over it, and they work great. You can see some of the apparatus inside there. It's kind of hard to explain how it all works, but the router also has a plunge feature. The way it sits right now, you can see that I have the bit just above the table itself. I'm going to raise the bit up a little bit. And from that point, I'm going to say that's my finish point. That's my top height of my cut I want. But I don't want to cut that all at once. So I have another, down below here, I have another handle. And what that does, that's going to lower everything. But it still maintains my height when I push the pedal. Now as I'm doing this, you can't see it, but the pedal's actually coming up. The pedal's coming up as much as the bit's going down. Now you can see on top there, the bit is actually gone. I actually lowered it below the surface of the thing. I'm going to step on the pedal, and you can see as I step on the pedal, it plunges up. You can see from underneath here. And it's actually cable driven. But that works pretty good. The fence itself, I wanted to use T-track, but having this construction track that electricians use to hang fixtures, and it's used in a lot of commercial work. It does have a lip, and I can bolt things to it. I don't have any fixtures yet, but I plan on making some to be able to utilize that. The back of the fence, I have I don't know if you can see it. There's a vacuum port in the back, and these are the screws that I made for the to bolt it down to the top. I have a series of 3 different holes in the top where I can move this fence about 6 to 7 inches back and forth. I guess that's about it. As I build things with it, I may post some videos. You can see down through the top a little bit. Here's another look inside the back. There's my foot pedal. That's about it.